How are you guys doing today? Good? I'm doing fine. But see, the weather is so gloomy, and for gloomy weather, people feel gloomy for no reason, right? Me too. Thank you for coming today. I also really want to come. It's like, oh, I can't. Okay, so as you remember, our exam will be when we come back on Tuesday. Next week we have class Tuesday, Friday, right? Yeah. Next week we have class Tuesday and Wednesday. Both days. But most likely we will get it today. Alright. Okay, so we'll take our time. This time I think we have enough time to do a review, right? So we are going to do a review on Wednesday. And our exam will be when we come back on Tuesday. The first Tuesday? December 3rd.
You post lectures online like Tuesday.
It depends. If I have time, I do it right after class. If I forget or I'm busy, then I do it at night. And if I forget at night, I do it next day. But I'll try to do it after the class. No problem. So you're almost done with chapter 12. Only few topics left, and then you'll be done. So to refresh your memory, we have to memorize these rules. There are few rules about log, which you're going to use in every log section. Like if you work with log in your pre-calculus or calculus or beyond calculus. Sean?
Yeah, I think I'll pass that.
Yeah.
Thanks so much. Appreciate it. Yeah. Sorry.
What I was saying?
Log.
Log. So it doesn't matter which math you take. If they have log portion, you must read this. Log means the rules. Okay, all the properties log has, we have to apply them in order to do anything with the log. If you want to solve log problem, these rules. If you want to simplify log, these rules. If you want to expand the log, this rule. If you want to combine the log into one single log, these rules. So these rules are the base for everything about log. So make sure somehow you memorize them. Okay. So the suggestion I gave you is that write them down on one paper and then look at it every day for a few minutes. The more you look at them, the more they get stuck in your brain. So it will be easier for you to remember when you need them. Based on this, in our last class, we simplified few things. And I also noticed in your homework. Did I notice? No, I didn't notice. I forgot to do that. Yeah, so in your homework, I think you have few of these simplifying things. And then the next thing we did was expanding log. So depending on how many things we have, how many elements we have in our argument, we have to have that many log. So here we have 3 things, so we end up getting 3 logs. Once we expand the log, if it's simplificable, we simplify. Otherwise, we leave them alone. So anytime log has a power, log hates power. Okay, he wants to be the most powerful one. So when he sees some power, it just brings it down as a coefficient. So you must need to bring them down. And then we did few examples like this one on the denominator. Under the square root, we have more than one term. So you need to split your square root. Anytime you have more than one thing under your radical, you always have to split the radical to each one of them. And then you apply the log and then bring the power down. Now we are going to do one example of this to refresh our memory, and then we are going to do the other way around. Many logs will be given. You're going to combine them into one log. Okay. So how are you going to split them? With addition sign or with subtraction sign? Which one? Addition. Multiplication means addition. So we have 3 things. That means we are going to have 3 log. 1 ln, 2 ln, 3 ln. Each of them will get each from the inside. And since they all are multiplying, So between them, we are going to have plus sign. In other words, basically, you can think of it as we are distributing the log. When you distribute, you don't use multiplication sign between them. Use addition sign for multiplication and division for quotient, Gerald. Then what? See, all of them have exponents, but log hates them. So we need to bring them down as a coefficient. So in the next line, we have 3 ln of a plus 4 ln of x. And when you bring the -5 down, it becomes -5 ln of y. So we apply the first rule, multiplication. Second rule, the part. Can you simplify more? Yeah. Which one? You have to take out ln. Good. E and ln, they're enemy of one another. Whenever they're next to one another, they always fight and they will die.
Well, 3 plus 4 at
3 plus 4 ln of x minus 5 ln of y. You don't have to put parentheses, but sometimes I do it. It's my habit.
So what is
Because they're inverse of one another. Just like 1 and -1. When you put 1 and -1 together, it becomes 0. So it gets vanished. Same thing here.
So we can combine 3 and 4 and then 7 and right? Because 4 and then the next thing like what is the thing? Like 4i.
Like multiplication, PEMDAS. PEMDAS is do the multiplication first and then addition. So we don't know how to multiply that. How can we get? Any other question? Let's refresh your memory with one division. So let's say we have one more, because here we don't. Let's say we have E 3x square, and then let's say E x, not x, y to the 7 and z to the 5. The fact doesn't do it on their paper. And then Chris, how are you doing today? You sounded so frustrated in our last class. I felt really bad.
That's fine. I just didn't.
But did you study? Did you review your exponent rules?
Yeah, I've been too well, so I just did.
Yeah. It's 97. And in the final exam, we'll have at least one of these. Exponent log. So from the log section, you have to graph transformation of log, expand, simplify, this other way around, solve logarithmic equation. Yeah, 4 questions will be from log. And from exponent, also 4. Transformation, solving maybe 2 or 3. Transformation from exponent, solving exponential equation, and then real life application, two of them, one from the money and one from the population. Final. Also in the exam. Because my exams are based on the final. Whatever you're going to see in the final exam, I'm going to put them in the. Ready, guys? Nazima, go ahead. Ellen and then? But 3 and x, they're two different things, right?
ln3
Mm-hmm.
plus lnx2
Mm-hmm.
minus lnp
Mm-hmm.
minus lny
Mm-hmm.
minus lnz
Mm-hmm.
ln3
ln of 3 plus
2 lnx
2 ln of x. Yeah, I got the habit. Should write in
minus
this.
1
Minus 1.
minus 7 ln y
7 ln of y.
minus 5 ln z.
Minus 5 ln of z. Yep, perfect. You didn't have to put parentheses, but it just automatically, right, by my hand.
So why is it?
Because everything on the denominator will get negative sign. So ln of e will be negative. ln of that will be negative. ln of z will be negative. The e and ln they cancel out.
Yes, sir.
Yeah.
When they cancel out, they become 1.
So,
Then it becomes 0. It's 3 times 1, but it's just,
oh,
if you just did times 0, you would have 0 there. ln of e equals 1.
See,
I didn't tell you that before,
you said they just cancel.
and I didn't complete my sentence.
I don't
They
know.
cancel out and become 1. You probably forgot. When they cancel out e and ln, then it becomes 0. They become 1. Just like multiplication. If you multiply 2 with 1/2, do you get 0? You get 1. So e and ln, they're inverse of one another. So when they cancel out, they become 1.
Does it matter the order in which you put the numbers? Like we have to put one first, no?
You can do it any order. Okay, any other question? Now you're going backward. We are given a bunch of logs. We have to combine them according to their signs.
So we have to basically move back. or
Go backward. The possible every coefficient becomes power. So step 1, bring the coefficient on the power. Step 2, according to their signs, if they're plus, they will be multiplied on the top. If they're minus, they will be multiplied on the denominator. Let's do one together. So we are going exactly backward what we did here. Step 1, we don't want to see any coefficients. So we are going to convert them into power, into exponent. So we get log x cubed minus log y plus log z squared. Now we are going to have a big log. And we have plus and minus sign combined. So that means you're going to have something on the top, something on the bottom. What goes on the top? X cubed, because it is a plus sign in the front. Y goes where? On the top or on the bottom?
Bottom.
Bottom, because y has a negative sign in the front. So negative means bottom. How about z square?
On the bottom. This is on the bottom because it's adding to y.
But what sign you have in front of log z square? Plus means where? On the top or on the bottom? Top. See? Every plus means they are going on the top. Every minus means they're going on the bottom.
It doesn't matter that we put it in that order, because when we solve it, we first do all the plus.
They wanted to confuse you to see you
Oh, I see.
whether you understood the process or not. Backward. So we only one log z, sorry, only one log negative, that means only one times the negative. So one from the bottom. And two plus sign, that means the argument for both log will go on the top. And they'll multiply one another. Is it clear? Any question for anyone? Okay, more. Box. Same rule apply. Second one has only one argument. They have plus in between them, but it doesn't matter. It's only one argument for that log. Matthew, are you done or you're thinking? Done? Wonderful. Would you like to try this? Eight to the eight. Oh, you're giving the answer, so go here. ln of 8 to the 8 on the top. 2b plus 1. They don't have any parentheses around them. They must, because here they inside the parentheses and there are more than one term. Why negative 1/3? That's why I think the second line is important. Stephanie, give me the second line, please. ln of
In the second one,
second line.
second of the bottom,
One line is missing.
the third of C. Like cube of C.
True, but see, people get confused about negative sign and that. So writing the second line is important, where you change every coefficient as an exponent. So 8 to the 8, 2b plus 1, ln of c to the 1/3. Now, Matthew, what is your power? See, it's 1/3, not negative. Because of the negative, we are putting on the bottom. But the power is positive 1/3. And 1/3 is cube root.
Exactly, that's what I'm gonna ask you. Don't we put the cube root on the
You don't have to, but it will look nicer. So you can write cube root of c. If you did it, then it's correct.
Yeah.
Either one is correct.
So it will depend on the options that they give.
I feel like they're gonna test more on exponent formulas. But if it's like you're running.
In my exam, I'm going to treat you. I'm going to give you plus and minus combination. So you have to see, plus means top, minus means bottom. Plus means top, minus means bottom. So you're going to play with your plus minus sign. So this is easy, right? Plus means you're putting both of them on the top, minus means in the bottom. But I like that one. Because it's confusing. Plus minus, plus minus. Okay, any other question? Let's see, do I have more? No. Fun is over. We have new fun stuff. We don't know how to find log base 3 of 5 in the calculator. In most calculator, okay? Some calculators are special, they have that option, but not every calculator. So for every calculator, how do we find what is log base 3 of 5? Since not every calculator has that special feature, so mathematician says, don't worry, all you have to do is change the base and you'll be able to find it on the calculator. So you're going to use change of base formula. The first one says use the change of base formula with natural log. It means we are given log base 3 of 5. This is same as we can write ln of 5 on the top. We are dividing that by ln of 3. Now we can use calculator to find out how much is this. Okay. We can do same thing. We can use log or ln. It doesn't matter. But if you put ln, then both must be ln. If you put log, then both must be log. For example, here it says find this one, but this time is common log. Common log means the normal one. So log base 7 of 11. We don't know how to find in the calculator. So we can simply write log 11 divided by log 7. You can use any calculator, but they recommend 89. You can use any calculator, I don't mind. As long as it's advanced, like scientific, with some type of features. Not every scientific calculator has every feature, right? So we see so far in our class many examples like my calculator works really better than the computer. So if you have a calculator like the computer one, it's not so good. So in this two example, you don't have to do anything else, it just says rewrite. But in the exam, I'm going to ask you to rewrite and then find the answer. So if you want to find the answer, we go to the calculator and punch this, they'll give you the answer. Please.
It's the same formula for natural log.
And normal log. So let's do this. Just to practice. You don't have to do it for this question, but for practice, ln of 5 divided by ln of 3. So in my calculator, first I have to punch the number and then log. So 5 ln divided by 3 ln. Enter, that gives us 1.465. 1.465. You'll get the same answer if you use log. Let me show you that. Clear. 5 log divided by 3 log. 5 log divided by 3 log. Ta-da! Same answer. But if you have 1 log and 1 ln, you're not going to get same answer. Let's try that. Let's see. So let's start doing log 5 over ln 3. 5 log divided by 3 ln. See? Completely different answer. So log and ln, you cannot combine them. They are log, okay, but they're two different types of log. The normal log has base 10, but ln has base e. So they have completely different base. That's why you cannot use them together in one question. If you want to use log, you have to have both log. If you want to use ln, you have to have both ln. Any question? Okay, go ahead. First step, change the base. Second step, find how much it is. And these are the final exam type of question. In the final exam, we'll have at least one of these. Final. And it says round to nearest 100. 100 means how many points after the decimal? 3, 2. In normal 100 is 3 places, but it's 100 with TH. It means 2. So in the exam, I definitely want to see you're using change of base. It doesn't matter which calculator you're using. You may have this feature in your calculator, but I don't care. I want to see the change of base. You know why? Because I had a bad experience with this question. When I taught it for the first time in person, so I wrote in my direction, use change of base to find it and show you work. Nobody showed work. Everybody wrote me the answer. So I was like, well, I know that not every calculator has this feature that where you can plug this in and they'll give you the answer. That means only one person actually did it honestly, and the rest of them either copied from him or her, or there is internet. So I was upset during that day. So when I came back, I asked everyone individually, did you do it by yourself? Oh yeah, I did it on my calculator. Otherwise, the what? I did it in the calculator. Okay, no problem. I'll trust you. Show me how did you do it? Nobody was able to do it. I was like, seriously? You even don't know whether you have the feature in the calculator, and you are telling me that you did it in your calculator? Sorry. Cindy. No, it doesn't matter which one.
So can you just a lot too?
That's why I showed you that example. If you use log or natural log, you get the same answer. But the condition is both of them have to do the same thing.
Even if we have natural logs and different
A log.
normal logs, doesn't matter. Okay.
As long as you're using the same thing, it's fine. So do you have the answer? So what's the answer?
It's log 479 over log 5.
Log 479 over log 5. Or if you want, you can write ln 479 over ln 5. And the answer is
3.83.
3.83. Did you round?
Yeah.
Okay. Give me without rounded number. Okay, so 3.83. See how easy? You don't have to do any math. Calculator will do the math for you. All you have to do is show me this. If you show me this, I would believe that you punch in the calculator and you get the answer. One more. So my bad, wait. Ln 361 over ln 3. 5.36. What's the next number? 0. So 5.36. If you tried it log, do you see here the same answer? Right? So these are easy, right? Easy one question in the final answer. Now, let's go to the last topic of the log. Solving logarithmic division. And just like exponential equation, we work with 5 types of exponential equation. Here, we have only two types of logarithmic. Only two types. So before we go into the logarithmic types, you should remember one rule. It says, as long as you have the bases are same, you're allowed to cancel the bases, set the arguments equal to one another, solve for s algebra. Just like the base rule for the exponent. For exponent, exponential. For exponential, we had a rule that if you have b to the x equals b to the y, as long as they are same, we can cancel them. Do you remember the rule? And then we set the power equal to one another and we solve for x. Same is true for log. If you have only a single log in one side and another single log on the other side of the equal side, you can cancel the log, set the arguments equal to one another, solve for x. Now, the other thing you have to remember is that converting logarithmic to exponential. We actually don't know how to solve logarithmic equation. So once you have this step in your equation, where one side is a log, other side doesn't have a log. So in that case, we cannot cancel the log. Since you cannot cancel the log, so we are going to convert the log into exponential. So if you remember your cycle, b gets c as a power, and we set that equals argument. So b to the c equals the argument of the log, and we solve for x algebraically. So these are the main two sets we have. And just like radical equation or the denominator point is solved, rational or radical equation, we always have to check our answers. Log has the same problem. Just because you got some results, it doesn't mean they're correct. You have to check your results by substituting into the log and see if you have any negative answer in the argument. If the answer makes the argument negative, we cannot accept that because log of negative argument doesn't exist. Now comes first type. In this type, we have log in one side and not log in the other side. These are type 1. Type 1. Log on one side, no log on the other side. Since we don't have two logs, so you cannot cancel them, we have to do what? If you have only one log, what do you have to do?
You have to
Turn into an exponential equation. But log doesn't have any base, right? So what is the invisible base for ln? E. 10 is for normal log, 10 is for log. But for ln, it's invisible E. So we have an invisible E here. So we convert that into exponential. We get e to the 6 equals 2x minus 3. Or if you forget about that, no problem. Ln of 2x minus 3 equals 6. If you forget that ln has a base e, all you have to do is apply ln to both sides on the base. They will do the same work. E and ln cancel out. We have 1 here. And the other side is e to the 6, e to the x, e to the 6. Our goal is to solve for x, right? So get the x alone.
There's always an imaginary key as the base for it, but doesn't have to be capital whenever an element be together, doesn't it?
That's why we don't write the E, because E and L together, they cancel out. So this E is invisible.
Yeah.
If you make it visible, they cancel out.
Okay, so you can choose.
So whenever you put visibly E and ln next to one another, they cancel out. Just like our enemies. If our enemies are invisible, we cannot fight with them, right? But when it's clear, we definitely can fight. So if you want to get our x ln, what is our first step? Add 3. So we are gonna add 3. So we have 2x in one side, e to the 6 plus 3 on the other side. We cannot combine them without using calculator because we don't know what it is. Now what is our last step? Divide by 2. So we have x equals e to the 6 plus 3 divided by 2. Either leave it alone if it's in the non-calculator portion, but if it's in the calculator portion, we have to solve it. So on the top, we have e to the power 6. We are adding 3 with that. Whatever we have, we are dividing by 2. 203.21. Let's just round to the 10th place. 21. 10th place means how many places after the decimal? 1. So 203.2.
And if it was not the compare function, we have, for example, e to the 6 plus 6 over 2. We have to break them into two fractions. Like
You can leave it alone. But just because we got some inside doesn't mean it's correct. We need to substitute inside the ln and see if we substitute 203 with x, does it become negative? If it does, that means it's not correct answer. Right. So you have ln of 2x minus 3. Our x is 203. So we have 2 times 203.1 minus 3. This is definitely bigger than 0. So we accept our answer. Right? 203 is definitely bigger than 3. So answer is positive. Please question. And if they're positive, we accept that. Actually, the reality is that we have to substitute and then see if the left side equals right side. But I realize that we don't have to do that because most of the time the number works if it's not a negative sign. You don't get a negative inside the argument. So go ahead, you try one. Which is even easier than the other one. But the same rules apply. Same steps.
So equals d to the fifth power.
So if you apply e on both sides, you get 2x equals e to the 5. And then
I divided by 2. I got x equals e to the equals 2.
x equals e to the 5th divided by 2.
I don't know if I put it in 4.3. And I got it talking to
74.20. Oh, it's next 1,000. 1,000 is how many places after the decimal? Really? First one is 10th. Second one is 100. The third one is 1,000. So you have to go 3 places after the decimal. So give me 4 places. 20? 2065. So since you're rounding here, we need to look at this. So 74.20. No. 7. We round based on the next number. It says round to 3 places, but since our fourth number is bigger than 5 or equal to 5, that means you have to round up. If the number next to our rounding place is 5 or above, our rounding place has to go up by 1.
the final answer is
Mm-hmm.
I'm not understanding. I saw that it says thousands to be in total 4 numbers.
1,000, if you have 1,000 without th, it's 4 number. But it's 1,000th with the th. So after the decimal, we don't have any ones place. After the decimal, the first place is 10. The next place is 100. The next place is 1,000. Before the decimal, this is the one place, 1. The next one is 10. The next one is 100. The next one is 1,000. Because these are before decimal. But after decimal, we don't have the first place. We lose first place to the decimal. These are the decimal rule. Any other question? Okay, same thing, but we start with this time it's with log. We have log in one side, no log on the other side. So you cannot do anything, you cannot cancel the log. That means we have to combine. What are you thinking?
Make it an exponential.
Exactly.
Oh,
So in my eyes, I combine, not combine exponent.
Can you do the arrow like
Cycle. So the way I remember is like a cycle. We start from the base. Base gets that as a power. Whatever we get, we set that equals to the argument.
that's all for x?
It's 11:20 seconds. Angel here, Stephanie here. Mary Elvis. Grace here, Cassandra. Absent. Angie here, Parker here, Tenzin here, Yaribel here, Julia absent, Gavin here, Gerald here, Vansh here, Yvette here, Ryan here, Christian here, Ian here, Joe here, Janelle here, Dunhill here, Isabella here, Dua absent, Nazima here, Zifan here, Matthew here, Chris K absent, Cindy here, Melanie here, 20 absent, Shri here, Jocelyn here, Jessica absent. So, any question?
Yeah.
Not?
Well, I don't know if I did it right.
Give me 1 second. Kelly, Daniel, Alex, Daniel was absent. Sophia was here. Evelyn, Kathy, Aaron, Alex, Jonathan, Shannon, June, Roger, Kathleen, Shelley, Ashley, Veronica, Ben, Santiago, Spider, Safe. Anyone else would like to try besides Stephanie and Nazima? Anybody else wants to try it? No? Okay, give him a chance. Go ahead, please.
I'm not very confident,
It's okay. She is also not confident.
so. I'm that you go through the power -1.
2 to the power -1.
One of that plus one.
Perfect.
Then you go send that into -2.
-1 power has a rule. Do you remember this rule? X to the -1 means? You forgot? Stephanie, do you remember the rule? 1/x. It becomes a fraction. So it's 1/2 equals 1/x plus 1. But your first step is correct. At least you want 1 point. Can you do it from here? What do you think will be the next step?
Well, guess we've got to isolate that. So,
How?
what's that?
How?
Multiplied by x plus 1.
Both sides, right?
Both sides, yeah.
You can do that. Or there's a shortcut. Since our x is on the bottom, we want it on the top, just flip it. Flip both sides. The x plus 1 will go on the top, 1 will come down, 2 go on the top, 1 will come down. Or you just do x plus 1/1, flip it because we want our x on the top. But since you flip one side, you have to flip the other side. So it gets 2/1. And now it's become very easy. 2 equals x plus 1, right?
That is a lot easier.
True. But if you use this method, no problem. We cancel this, so we have x plus 1 over 2 equals 1. Now I don't want the 2, so multiply both sides by 2. I'm showing both methods.
So both get one. It's just
Mhm.
one.
One is simpler and one is a little bit more work. We end up getting the same thing here. X plus 1 is 2. See the exact same thing we have? But here you did in 3 steps, and here you did in 1 step.
I did. But you got X plus 1 over 20.
It's okay, because when you divide by 2, the 2 get vanished from the denominator. So it doesn't matter which method you use. At the end, if you go in the right direction, it's fine.
You know what I did?
Mhm.
When I multiplied 1/2 by x plus 1, I got 1/2 of x plus 1/2. And then it was like, I did it like a longer way. I don't know if it's-
Math is trick.
Yeah.
Math is all about tricks. The more trick you know, the more easier you become. Okay, so from here, how do you solve for x? You simply subtract 1, right? It doesn't matter which one you do, you end up getting x equals 1. See? Are we done?
No.
No, we have to check. So let me do the checking here. This. Check. We just want to see if the argument is positive or not. So argument is 1 over x plus 1. When our x is 1, we get 1 over 1 plus 1, which is 1/2. It is positive, and we are fine.
Oh, so the argument has to be positive, not negative.
In reality, you have to check everything, but for my class, you don't have to check everything. If the argument is positive, it will work. Okay? You must. Because they'll give you one question that doesn't work. I mean, you get two solutions. Mostly one of them will not work. The other one will work. Just like radical equation. Do you remember solving radical equation? You always get 2 answers, but when you substitute, usually one didn't work. The log is like that. You get 2 answers, but one of them will not work. Okay, try the next one. You need calculator.
You need calculator?
And this is actually only one step solution. You get the answer in the first step. Did you notice that? Few places. Usually in the final exam, they tell you what to round. Or they'll give you the options. So you have to pick the options based on
Say how
what
many
it is.
days?
3. Huh? No. We cannot work with different reason. Parker, you are up. But in the exam, if you do that, you're gonna get 0. Because you need to show your work. You can use calculator to solve, but you have to show me your step. So what's the step we have here? And what's the base? We don't have natural log, we have only log. Only log has what base? E or 10, which one? 10. So if you put E, you're gonna get a different answer, which is wrong. So it's 10 to the 2.2 equals X, right? And how much is that? 0.342. Give me the next place also. 4. So yeah, 0.342. Is it different?
It's
Well-
10 to the power of 2. And then
10 to the power 2.2.
I got 158.48.
Well, yeah. 10 square is 100. How can I get decimal, Parker? No, that's different thing. No, we cannot actually solve this in the calculator. So if you put log 10 2.2, it's wrong because this is not what is given to us. What is given to us, 10 to the power 2.2 is X. So basically this means we have 10 to the power 2.2.
I got that. I have a question. But if we don't have to worry about that because since we don't have a base, the calculator already knows that log has to make
Exactly.
sense.
So what did you put?
I put log parentheses the answer that I got for X, and then I
That's
got,
the question. What answer you got for X?
I got 158.489.
Me too.
158.489.
8.489.
158.489. The next number is 3. So Chris, what question you have?
No, that was it. I was just wondering what we were rounding up to. So it'll be the 10,000.
489.
I would do the
3 places. Okay, so Chris, you need to you need to convert every log into exponential. If you have only one log given to you. So I must want to see this step. If you don't show me this, but suddenly give me the answer, I'm going to give you 0, guys. I'm telling you. Giving me answer without giving it a word, I do not accept that. You already know my habit, right? I'm very strict on that. I want to see your word and then the answer. And this is the most important part, converting log into exponential. All this equation we did so far, here first step is conversion from log to exponential. So give me the word, show me how to come up with the answer. Even use a calculator, it doesn't matter. The steps, we need to see that.
And that's the rate for our final.
Mm-hmm.
You get a grade of 5.
Mm-hmm.
But no, there's partial credit or no partial?
In the final exam, no partial credit.
So, sorry, what stops us from just putting down the final answer?
Huh?
So there's nothing really stopping us from putting down the final answer without knowing working out. Because if it's just final result, no partial credit.
No. We don't accept the final answer if the work is wrong or the work is missing.
So the work has to be right and the final.
And the final answer is correct. Right. The next is type 2. In this type, we have 2 logs. 2 logs on one side. First let everyone try. And the number on the other side. Actually, let's do it together. So go ahead, Nazima.
Log 1, log 4.
See, when you have 2 logs, you don't know what to do. When you have 2 logs, we cannot work with them. We need to convert them into 1 log. Because when you have 1 log, we can convert them into exponential. So 2 logs means we are in a bad shape.
I have a question.
Go ahead.
Does that mean that we're gonna have a log with a fraction?
Do you remember how to combine multiple logs into one log?
Yeah.
So what's the rule we did? We keep our log and multiplication becomes what? Sorry, addition becomes what? So we have x times x minus 6. The left side becomes only one log. And now it becomes the first type. Only one log in one side, number to the other side.
And we don't distribute the x.
We will.
We will.
You can do it either here or you can do it in the next step. So once you have only one log to work with, we get stuck because we don't know what to do. They convert them into exponential. So what do we have?
Now we have x minus x minus 6.
4 square equals x times x minus 6. I have the square on the other side so that I can bring it to the right side. Is it confusing to you guys? All right. All this time I did 4 square equals this, but now I want to do the other way around. I put my 4 square on the other side.
All right, that's sort of all logs at the same base, so I did 4 equals x squared minus 8.
Same thing.
Wait, that's the same thing.
Same thing. So is it? It is confusing.
Is that the
So
one-to-one gap thing? Like, is that?
4 square equals x times x minus 6. And even though it's same, but you know, our brain works so weirdly. When you're too used to seeing one thing and suddenly we see the other thing, our brain doesn't, sometimes it doesn't connect them, cannot connect them. So it's okay, if it doesn't connect, no problem. Do your cycle. So we have x squared minus 6x equals 16. Right? I wrote my x on the left side, so all life will be normal. So what do you do next? Since we have more than one x, we want everything to one side. So that we can do what? Factoring. See, anytime we have x squared, our goal is to factor.
That every time we have two x's, like one squared, we have to factor.
Factor. Either you're going to use factoring, if it's factorable. If it doesn't, then you need to use the quadratic formula. But usually in this class, all of these are factorable. I'm not too sure about the homework, but in this class, in the exam, they are factorable.
The lead one is not factor.
Hmm?
The lead one. The next one is not factor.
Really? You always tried
Not
that?
the last.
The last one? We'll see what method to use. So what two numbers? When you multiply, you get 16. Negative 8, positive 2. So 8 times 2 is 16. 8 minus 2 is 6. Yeah. So x minus 8, 0. X plus 2, 0. That gives us x is?
X is 8 and negative.
X equals negative 2. Are we done?
No.
We cannot stop here. Even though you see this in the multiple choice, but if you pick down, whatever you did so far, everything will be 0. Let's check the first one. X equals 8. X equals negative 2. So this time we have two arguments. One is x and one is x minus 6. Right? So we have log x plus log x minus 6. When our x is 8, this becomes 8, this becomes 8. So we have log 8 and log 8 minus 6. 8 is positive, so we are fine. 8 minus 6 is positive, so we accept. So we clearly accept x equals 8. Now, what happens when x is -2? We get log x plus log x minus 6. When our x is -2, what happens to the first log? Can we accept negative log? That means we don't have to check the second one. If one of them is not acceptable, we cannot accept that as our solution. So the only answer we have is this.
So save yourself enough time, if you get in the x variables or negative, that means the positive.
Not always true. You have to see the argument. Here x is alone, so we can see negative means not acceptable. But if you don't have x alone, let's say you have x plus 1, and you have -2, how can you know it's not acceptable if you don't do -2 plus 1? You have to substitute and then see. Just because you get some negative, it doesn't mean it's unacceptable. Sometimes negative does work. That's why you have to substitute in the argument to see what the result for the argument, positive or negative. Is it clear? So we've seen two scenarios so far. In first scenario, you have one log and the other side is a number, so you convert into exponential. Second time, we have two logs in one side and the other side is number. So what you do, first we combine the two log into one and then we transfer them into exponential. Go ahead.
You said that whenever the argument is negative, we can't accept the answer.
Because log 0, log negative doesn't exist.
Okay. What if we have, say we made a mistake and we got a positive answer, but
then
we got like a positive argument that the answer is not the number that's supposed to be exactly correct?
If the solution doesn't work, it's wrong. For example, you got something that makes it positive, but actually that's a wrong answer, it's wrong. But if you want to be sure, then substitute and redo the work,
Like
the whole work. So one more, pivot. It's same as the second scenario. Two logs in one side and a number on the other side. And then we have a third scenario. So for log, we have this scenario. For exponential, we had 5 scenarios. I should write them down. Log of 3 scenarios. And all of these are finalism questions. So after substitution, if you have a 0, we cannot accept that answer. Or if you have a negative, we cannot accept that answer. Log 0 doesn't exist, log negative doesn't exist.
How many can are you going to have? With multiplication or with division? So what multiple times? Multiplication or log it. Why you edit? Because multiplication. Why you edit? Same as what you did here. The first thing we did today. The second thing. We did this. Here. You have your many logs to combine them based on their count. If they're plus, we multiply them. If they're minus, we multiply them. So we are using this for what you. We have two logs switching them in a plus sign. So you can combine them into one log, we multiply them, we multiply their Joe, give me the. Probably people might help you. You need to plug it into the log to see the log becomes. You get one, so by coincidence, which is like always one. That's the thing. I think it's me. What is highlight of the contrast? It goes 4 to the hard. I hate it. These are about so one I just started to. Wait, actually, like never. But I think. And yet.
What about the
Yeah. Yeah.
This is not. I like, you know. Yeah, do I? Like,
Step one, for this type, we don't know how to work with two logs, so we combine them into one log. So we keep our log. And how do you combine the addition? Multiplication. So x minus 5 times x plus 7. We use the single log property equals 3. Now we get stuck because we don't know what to do with the log. So we go to the exponential format to help ourselves. We have 4 cubed equals x minus 5, x plus 7. Now when you use FOIL, you get x squared minus plus 2x, right?
2x, no.
X squared plus 2x minus 35.
Yeah, 2x.
Well,
7x minus 5x.
Plus 7x minus 5x. And what is for cube? 64. Since we have more than 1x, what is our goal?
Minus 64 on both sides. Now get you.
X squared plus 2x minus 99. And 99 is a good number. When you see 99, what two numbers comes in your mind? 11 and 9. So 11 times 9 is 99, and 11 minus 9 is 2. So we found our two factors. How confused?
Yeah, I confused myself.
Plus 11. Quadratic formula? Come on, 99 is an easy number. Anytime you see double number, like for example, 88, 99, 77, 66, when you see those numbers, 6 and 11, 7 and 11, 8 and 11, like those two numbers supposed to come in your mind.
You know what?
Really?
You know what I thought?
Oh.
I was actually 5 and x plus 7. From there, I got the x squared plus 12x.
Do it.
You still want me
Yeah, write the correct answer.
Absolutely.
So actually, the double digits number are same number times 11. So this supposed to comes in your mind. So from next time, remember, double digit same number means number times 11. So we got x plus 11 equals 0. That gives us x is negative 11. X minus 9 equals 0. That gives us x is 9. But just because we got them, it doesn't mean they both will work. So we have to check them. Negative 11, positive 9. We have log x minus 5, x plus 7. If you want, you can use the second part, the single log. So that gives us log negative 11 minus 5. Sorry, my bad, you cannot use single log. If you do, that means you get positive answer, which is wrong. Yeah, negative becomes positive, but you cannot accept that. So negative 11 plus 7. This is minus, this is minus. We don't even have to check the next one. Since the first one is minus, we cannot accept our 11, negative 11. If one of them, at least one of them is negative, we cannot accept that. Sometimes none of them work, okay? So you must check both of them. So we have log x minus 5 plus log x plus 7. When we have 9, we get 9 minus 5, which is positive. 9 plus 7, which is positive. So both of them work for 9. So x equal 9 is our answer. Remember, you must check both of them because sometimes they are plus, but it doesn't work.
And if none of them work, that means that we made a
No
mistake.
solution.
No solution.
Two choices. Either you make a mistake or no solution. Any question on this one? So now comes the third type. Type 3. Log on both sides with no single number. So we have only logs, no number. We are going to do the same thing. Combine the two logs on the left side into one log. So we have log 2x times x minus 3. The double log becomes one log. And we have log 2 of 3. What do you notice?
The answer will be
We have the same log. When you have the same log means log with the same base. When you have the log with the same base, cancel them. So we have x times x minus 3 equals 3. So x squared minus 3x is subtract the 3. And it's not factorable. Man, it's a better answer. Actually, let's make it easier. Let's say this is 4. If it's 4, we can factor it. And in the exam, usually it will be factorable. So don't waste our time. Let's say this is 4, 4, 4.
So I have to change my caption.
Let me change it now because later I'm gonna forget.
If it's 4, we are happy, right? It's factorable.
What two factors we get?
1. Also x
X is always positive.
plus 1.
Plus 1 and minus what?
4.
4.
4 times 1 is 4. 4 minus 1 is 3. So it works.
So we have x minus 4, 0, x plus 1, 0. X is 4, x is negative 1. What do you think? Both of them work or only one of them will work? Which one will work? For true. Because when you check negative 1, we have log x. We don't even have to write the rest. Because when x is negative 1, we get log negative 1 and it doesn't exist. So we cancel just by observing the first term. For the next one, when x is 4, we have log 4 plus log 4 minus 3 equals log 4. We accept everything. And I think with this, we are done with chapter 12. Yay. So my plan is for next week, Tuesday, we are going to chapter 13, 13.1. And maybe if you're done with 13.1, we are going to 13.3. And Wednesday, we are going to do it. I don't have any revision for the final. So we study all the revision for my first exam. There's the revision for the final. Goodbye, everyone. Have a good weekend. Don't forget to do your homework and quizzes.